Okay. The idea for this theorem is just to do the same thing that we did for the real numbers. Basically, we go by contradiction. Okay. Suppose, so obviously, it's clear that x is less than or equal to the power set of x. Because we can define f from x, the power set of x, by the rule, send an element of x to its singleton. That takes an element of x and maps it to a subset of x, and different elements get mapped to different subsets. So there's 1-to-1. That proves that we have this inequality. Okay, so we have to show that it's not true. We have to show that they're different. We have to show that they are not equal cardinalities. Okay, we suppose for a contradiction that f from x to p of x is 1-to-1 and onto. Okay, and we want to construct a subset of x, which is not in the image of f. Our goal is to find a subset of x such that we can't find any x for which f of x is equal to a. Oops. No. F of x not equal to a. Okay. So, how should we do this? Well, we just ask ourselves, is x in f of x? Our construction goes like this. For each x in x, let's see if x is in f of x, or the other possibility is that x is not in f of x. F of x is always a subset of x, and subsets of x can have, like, consist of elements of x. X is an element of the set x. We just ask, is it true that x is in f of x, or is it not true? Okay. And this is the exact same thing that we did for the real numbers, almost. If x is in f of x, then we don't put it in a. And if x is not in f of x, then we do put it in a. Okay. If x is in f of x, make x to not be in a. And if x is not in f of x, put x in a. Okay, and we can do that. We want to do that a little bit. I guess we should do it like more rigorously. You have to put a to be all the x's. Such that x is not in f of x. This is all the x's And now notice that if x is an element of x, then a is not equal to f of x, right? Because you know, if x is in f, if x is in f of x, then it's not in a. And if x is not in f of x, then it is in a. So there's like there's kind of like a difference between a and f of x. Okay. So a is not equal to any of the f of x's. So a is not in like so this proving that f is not onto. No matter how we constructed f, it can't be onto. And that it would be a contradiction. And it's a contradiction to our assumption that there's a one-to-one and onto function from x to the power set of x. So there's no one-to-one and onto function. We do have less than or equal to, so we just have a strict less than as required. So in fact, that's the end of the proof. And in fact, we have the natural numbers. Well, that's less than the cardinality of the power set of the natural numbers, which is equal to the cardinality of R. Okay. Okay. Oh yes. So before I didn't leave enough. I meant to leave more time for this, but I have a survey there for you guys. Oh, I've sent it to the wrong this chat. Yes. Okay. You know, if you have a chance, you can tell me your thoughts on this week. If you don't have a chance, it's okay. You know, not a problem. But it actually does help me. Anyways, I guess that's it for today. And just look out for assignment 6 later. So I guess that's it. I'll see you guys next week. Okay. Yeah, bye.